Okay, so hey everyone. In this video, we're gonna be learning how to graph linear inequalities. So, basically what you need to know about linear inequalities is that, so if it is greater than or equal to, you do a solid line, and also if it's less than or equal to, you do a solid line, and if it's less or greater than, you do a dashed line, and if it's less than, you do a dashed line as well. So I'll get to what that means in a second. So basically what you do for this one, so this one is, so you have y is greater than negative 2x plus 5. So what you want to do is you want to go ahead and plot your points. So you have negative 2x plus 5. You want to treat it as, you want to first say, like, treat it as y equals negative 2x plus 5. Even though that's not what it really is, you know, you want to make sure that you have your points labeled. So what you do again, you do rise over run. So you do 1, 2, 1, 1, 2, 1, down to right 1, and then down to right 1, and then down to right 1. Oops. And then again down to right 1. So then, I don't think there's, I'm not sure if there's like a ruler in here, but you do this and then you go ahead and you, since it is greater than or equal to, you do a solid line. So you do this, and now there's two ways to like know whether you shade in the right or the left or above or below, whatever. So you have to basically, you know, you have to, number one, you can either memorize where to shade, or number two, you can use test points. So, so if you use, let's say you do test points, so meaning test points that are above this line or to the right of this line, and test points meaning like right here, or test points that are right here, any of these, any of this area right here. So what you want to do is you want to go ahead and use, so for example, let me use 3, 1. So what I do is I say 1, is that greater than or equal to 2 times 3, or negative 2 times 3 plus 5? And the answer is yes, it is. So since it is, what I want to do is I want to go ahead and say that this entire area is going to be shaded. So we shade this entire area, meaning that when you shade this entire area, that means that all the points that are above this line are included in the solution to this inequality. So that's how you do it. And they shade it because they want to make sure that because when you say the difference between equations and inequalities is that you when you have an equation, so like an equation is more like if it was negative 2x plus 5, well, you can't say that 1 equals negative 2 times 3 plus 5 because that is not true. But in an inequality, you can say that because apparently it is greater than or equal to. So they want to make sure you show that it is true. So that's why you have to shade this area right here. And usually usually it's for systems of inequalities. I'm going to do something different. I'm not going to do it on here on the internet, but I'm going to do it more like as an example. I'm going to pull examples from the internet and do it on OneNote, just because that one you'd have to use kind of different colors. But anyways, I'll get to that when I get there, or we'll get to that when we get there. So right now we're just working on linear inequalities. So basically, for the second one, what you do is you do the same thing. So you go ahead and you plot your points and you do the slope. So you say one down and 1 to the right, and so you keep doing the same thing. So rise over run, which is your slope. And if you're not still good at graphing these or plotting points for these, I suggest you look at my other video about how to graph equations or linear equations. So for this one, since it is not equal to, what you want to do is you want to go ahead and you do a dashed line. So you do this. It doesn't have to be perfect, but it has to look kind of dashed. So there has to be little tiny, it can't be a full line, basically. So I'm guessing you can do this. So put arrows, but anyways, so then what you do to know where to shade, you use a test point again. So you want to determine the areas where you would use a test point, whether to shade over here or you shade over here. So you have to use any test point that is here, that is around here, and any test point that is around here. So I'm gonna first use, let's say I use something like 2, 1. So I'm gonna say 1. So I'm gonna use this point, and I'm gonna say 1. So test point 2, 1. So I'm gonna say 1 is that greater than negative 2 plus 1. So 1 is that greater than negative 2 plus 1. 1 is greater than negative 1, and that's true. So therefore, I shade above this line. So that's how you would do it. My bad. So, yeah, that's how you would do it. You would shade above this line, saying that all the solutions, like, above this line are, or all the coordinates above this line are solutions, because you can also say that, you know, that 3 is greater than negative 2 plus 1. And that's going to be 3 is greater than negative 2 plus 1. And 3 is greater than negative 1. So that's also a solution. So that's what I mean by, that's why you shade the coordinate or the graph, because you're saying that that's also a solution. Okay, so we're gonna do another one. So we have y is less than 0, and apparently we don't have a slope, so we are gonna say, so this is like saying y equals 0. So if you know, basically with a horizontal line, when you say like y equals 6 or something, or y equals a constant c, meaning like a constant, meaning like a number, or any number, you would do a horizontal line. And if you had x equals c, you would do a vertical line. So, or I forget what horizontal and vertical are, but you know, you would use, this is how it would look. You would use that for y equals c, and then you would say this for x equals c. So since it's y equals 0, you're gonna go ahead and make a line right here saying that all of these, oh, and by the way, since it's less than, you're gonna do a dashed line. And I know this one doesn't really have dashed lines, so I'm gonna do it in a different color to show that it's dashed. Okay, so basically, you then again do test points. So you go ahead and say, okay, so you go ahead and say, so where am I gonna shade? So you do, let's do this point, for example, 1, 1. So is 1 less than 0? No. So this cannot be shaded. Now, if you said, is negative 1 less than 0? That's true. So this part, like for example, this would be a test point. However, you don't usually plot the point that you're testing. You just do it. So then you would go ahead and shade this area, because that means that all of the coordinates on this area would be solutions to this linear inequality. Okay, so this one says y is greater than 2/3 x minus 2. So again, you would plot your y-intercept, and you would do you would treat it like an equation. So you would say 1, 2, give me a second. Okay, you would say 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. And you say 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. Okay. So this one is since it is greater than or equal to, you use a dashed line. So you would go ahead and you would do that, and then you would, and then you would say you would use a test point. So then once you do that, you use a test point that is above or below this line, above and below this line, to see where it's true, so that you would shade that area. So for this one, we're going to use 1, 1. So we say 1, 1. So we say 1 equals 2/3 times 1 minus 2. So then we say 2/3 minus 2, is that equal to 1? So then we go ahead and do common denominator. And then we say 1 equals 2/3 minus 6/3. And then we say, or my bad, we put greater than. Not equal. We put greater than. Is that greater than? So then we say 1, is that greater than negative 4/3? And that's a yes. So we go ahead and shade this entire area. So for this one says x is greater than 4. So what you want to do is you want to go ahead and again, when you have, it's like saying x equals 4, so you go ahead and do a line like this. But since this is greater than, since it's only greater than, you basically go ahead and do a dashed line. And then you go ahead and you say, okay, you use a test point. So then you say, let's say 5, 1. Is 5 greater than 4? That's a yes. So you go ahead and you shade this area right here, because all of these are solutions to this inequality. So basically for this, so then the next one, we have y is greater than x minus 3. So what you do is you plot your y-intercept, and then you treat it like it is an equation. So you say up 1 over 1, 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 and then up 1 over 1 again. So and then you say down 1, left 1, down 1 and left 1, and then down 1 and left 1. So then you make your dashes. And then you go ahead and say, you go ahead and use test points. So then we can use 1, -1. So we can use 1, -1 for this, since this is a point outside or above the line, the dashed line. So we can say -1 is that greater than 1 minus 3. So we say -1 is greater than -2. That's true. So therefore, we go ahead and we dash, or we shade above here. Make sure it's still recording. Okay. So, for this one, for these, what you have to do is you have to make sure that you, I don't know if I went over how to graph equations in I don't know if I went over how to graph equations in what do you call it, in standard form. But for this one, what you do is you basically try to solve for y first. So you say -8x minus y is less than -4. If it helps you better, you can go ahead and make the y positive. So you say y minus 4 is less than -8, -8x, and then you go ahead and say plus 4. Say -8x plus 4 is less than y. So y, then you flip it over to make the variable go first. So y is greater than -8x plus 4. So what you do is you go ahead and you plot your form, and then you go, again, like a linear equation, you go down 8 and right 1. So 1, 2, 3, 4, give me a second. 1, 2, 3, 4, 5, 6, 7, 8, and then right 1. And then obviously those are the two only points that I can plot. So then you go ahead and you make your dashed line. So it's kind of difficult when you have 2 points very close to each other. This one's a bit difficult, so bear with me, because give me a second, guys, hold on. So you want to, but yeah, you basically want to draw a dashed line. This one's not perfect. So then you use a test point again. So we're going to use let's see. We're going to use 2,5, since that is above the line. So we say -8. We can use this equation, or this equation, doesn't really matter. So we can say -8 times 2 minus 5 is that greater than -4? So we say negative 16, or is that less than -4? Negative 16 minus 5, is that less than -4? And then we say negative 21, is that less than -4? So yes, it is. So therefore, we go ahead and shade to the right or above the line. So, and you can look up what I mean when I say like memorize above or below, because usually they tell you, but you can use this method better to better understand in case you ever forget how to do it or forget the rules of how to plot or where to shade. So we're probably gonna do one more. So we have 2x minus y is greater than or equal to 3. Again, what you want to do is you want to solve for y. So you go ahead and you say 2x minus y is greater than or equal to 3, and then you remember that when you divide by a negative or positive, or when you divide by a negative or multiply by a negative, you flip the sign. So you're going to say y is less than or equal to 2x minus 3. So again, what you want to do is you want to or negative 2x minus, actually no, yeah, 2x minus 3, yeah. So you want to go ahead and treat it like an equation. So you do 0, -3 first, and then you use your slope. So you go up to right 1, up to right 1, up to right 1, up to right 1, and then for this one, down 2 and left 1, and then apparently that's it. So then you go ahead and you draw your dashed line, or your solid line, because it's greater than or equal to. So and then you pick a test point. So then you say, let's say that it's going to be 3 comma 1, for example. And so you can go ahead and test it. So you say 2 times 3 minus 1, is that greater than or equal to 3? 6 minus 1 is greater than or equal to 5, or is greater than or equal to 3. And you say 5 is greater than or equal to 3. That's true. So you go ahead and so it was 3 comma 1. So since that is true, you go ahead and shade over here, because it means that all these other ones are going to be solutions as well. Okay, and then we're going to do the next one. So we have 10x minus 3y is less than or equal to -15. So first, what you want to do is you want to put it in slope-intercept. So you want to do So you want to copy it. 10x minus 3y is less than or equal to negative 15. So you go ahead and subtract by 10x, get negative 10x minus 15 equals negative 3y, and then you go ahead and you divide by negative 3, you get y is greater than or equal to 10 thirds x plus 5. So go ahead and you say 0,5, and then you go ahead and do so I would do, it would go up and right, but remember that since we don't have enough space for that, we're gonna go down and left. So like it would look like this, but we're gonna go down and left. So we would say 1, 2, 3, 4. So would it be 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, and then left 3, 1, 2, 3. It would be right here. And then apparently, since we don't have other points, we just go ahead and do it. So try my best to do this one. So something like that. So it's I wish this feature still had one note, or still had a ruler in it. I don't know why they might have taken it off. Anyways, so then you would use test points again. So you would say let's say you use -5, or no, yes, let's say you use -3, 2. So let's test -3, 2. So you say 2 is greater than or equal to 10 over 3 times -3 plus 5. So then you would say 2 is greater than or equal to, and it would be a -30 over 3 plus 5, and then it would be a 10, or it would be 2 is greater than or equal to -10 plus 5, and it would be 2 is greater than or equal to -5, and that's true. So you would do, so since it was -3, 2, let's see, you would shade above, you would shade this part right here. So yes, it would be like this. So I hope that helped a little bit, and in the next video we're going to be learning how to do I believe we're going to be doing probably systems of equations. So that way, because I believe that's the next part of algebra. After you do linear equations and inequalities, you would do systems of linear equations and inequalities. So I'll be looking at that in the next video, and then, or probably in the next 2 videos, or in the next video. So stay tuned for that, and